Here we have an overall vector of length 5. The overall vector is w. It has a length of 5. And you can see it's forming an angle here of 70 degrees. And here's our x and y axes. Please try to break this overall vector into x and y components. Pause the video and give that a shot. Well, this problem might have seemed a little unusual to you, but I hope you had no doubt about the first step. The first step was obviously writing down the positive directions, right? We always start by writing down the positive directions, which means writing down the x and the y axes. So you can show the positive x-axis and the positive y-axis. And that really makes it apparent how this problem is different from what we've done previously. In all of the previous problems, I believe, we've been working with a horizontal axis and a vertical axis. We've been working with a horizontal and a vertical axis, horizontal and vertical components. But there is no law that says that the components have to be horizontal and vertical. Nothing says that the axes have to be horizontal and vertical. You can have any axes you want as long as they're perpendicular to each other. You can have any axes you want as long as they're perpendicular. So even though I didn't show it, it goes without saying that these two axes are perpendicular to each other. Axes are only legal and sensible if they're perpendicular. But as long as the axes are perpendicular, they don't have to be horizontal and vertical. They can be pointing any way you want as long as they're perpendicular to each other. All right, so now we have to learn how to deal with a case where the axes are not horizontal and vertical anymore. Now, at the very beginning of your physics class, you're usually going to work with horizontal and vertical components. But pretty soon, you're also going to be dealing with components that are not horizontal or vertical. Pretty soon, you're going to be dealing with components with axes that are neither horizontal nor vertical. So this is not an advanced technique. This is a basic physics technique. This is a technique that you need to master to feel comfortable with in your physics course. Even though you might not see this at the very beginning of your course, soon enough, this is going to be an important skill for you. So let's make sure we get this down. Well, the first thing we do is we have to, so by the way, the convention here should be that we should assume that this dashed line here is parallel to this y-axis. You can see, hopefully if I'm a good drawer, this kind of looks parallel to this. But anyway, it should be taken for granted that this dashed line here is parallel to the y-axis. So this is a 70-degree angle with a line that's parallel or anti-parallel to the y-axis. Well, we need to break this overall vector into components. We need to break this overall vector into components. Remember that this is not the y component anymore. In the previous problems, something vertical would have been a y component. But now the y component is not vertical. It's kind of pointing northeast or southwest. So don't assume this is the y component. It's not the y component anymore because the y component is not going to be vertical. This is the overall vector. The overall vector is pointing down. We have to break that into components by drawing a right triangle. We need to draw a right triangle that uses the overall vector as the hypotenuse. And remember, as I've been mentioning before, the legs should be parallel to the axes. The legs should be parallel to the axes. Now, in all our previous problems, the axes were horizontal and vertical, so we just drew a horizontal leg and a vertical leg. But here the legs should be parallel to these axes. Well, I can automatically draw a leg across this dashed line. This leg is going to be parallel to the y-axis. And then I can draw a leg that's parallel to the x-axis. So this will be wx parallel to the x-axis. And this will be wy parallel to the y-axis. And since the x and the y-axes are perpendicular, the x and the y components must be perpendicular. So that gives us our right triangle. So this is why I've been emphasizing in the past that when you draw the right triangle to form the components, the legs should be parallel to the axes. Remember, the overall vector forms the hypotenuse. Here, this vertical line is the overall vector, so it's the hypotenuse, and then the legs are parallel to the axes. Well, in this case, we have an axis that's looking like this. That's our x component, and another axis that looks like this. All right, so we really have to reorient ourselves and stop thinking in terms of horizontal and vertical, because we're not using horizontal and vertical components. All right, now I'm not really the world's best drawer, so this might not really be totally parallel and a totally right angle, so I hope that you'll kind of bear with me. But I hope that you can see what I was trying to do here, which was draw a right triangle that uses this vertical overall vector as the hypotenuse and where the legs are parallel to the two axes. All right, now we can put in our star for the information we were given and the angle we're focusing on. Let's label the hypotenuse. Remember, this vertical side is now the hypotenuse because it's opposite to the 90-degree angle. And this side over here is opposite to the 70-degree angle. And W sub y is adjacent to the 70-degree angle. You might have started to get out of the habit of labeling the hypotenuse opposite and adjacent sides, but this is a new type of problem where you might have a lower comfort level. So now's the time to use more notation again. Okay. Now, in some ways, this is a standard problem. We're trying to find the components based on the overall vector. We're given the overall vector, which is the hypotenuse, and you have to find the components. So we've learned that the adjacent side is the hypotenuse times the cosine. We use the cosine to find the adjacent side. Remember, if you ever forget this equation, you can just write that the cosine of the angle is the adjacent over the hypotenuse, and then if you cross multiply, you'll get this equation. But maybe at this point you're getting so comfortable that you go straight to this equation and you don't write this equation first. Plugging in, the adjacent side here is W sub y. But again, when we're working with trig, we're working with magnitudes and dots. The hypotenuse here has a length of 5. Even though this is vertical, it's the hypotenuse. And our angle, we could have plugged this in already, but the angle is 70. If you wanted to, you could have just used 70 from the start. Maybe I shouldn't really have used theta because I didn't label theta in the diagram. Maybe I'll go back and say this was 70. Okay, now we just get our calculator and do 5 times the cosine of 70. That's 1.7. This is still a magnitude, so I'm not going to indicate the sign. But then there has to be another step where I do find the sine component. Oh, it looks like I left something out, huh? I didn't put arrows on the components. That was a mistake. Let's go back and put arrows on the components. Well, first of all, where was the arrow on the overall vector? It's a little bit obscured now, but I hope you can see in your notes that originally the overall W vector was pointing down. Originally, the overall W vector was pointing down. And now we have to figure out how that translates into the directions on our components. So this is maybe a little bit tricky. What direction should W sub x and W sub y be pointing in? There's a couple of different ways to find the right directions here. One thing you might say is clearly the overall vector here is pointing down. So I should pick a kind of downward direction on the x component. Since the overall vector is pointing down, I should pick the kind of downward direction on the x component. And I should also pick the kind of downward component on the y component. Downward direction on the y component. Another way to put it here is we want two components that will add up to the overall vector. We want our components to add up to the overall vector. The overall vector starts here at its initial point and goes here, final point. The overall vector starts at this initial point and points to this final point. So if we follow along with our components, we should be able to go from the initial to the final point. Well, these are the arrows that will take us from the initial to the final point. We should go from the initial point to here, and then in this direction, and that'll take us to the final point. If we had put any other arrows on the components, we would not be able to travel from the initial point to the final point. For example, suppose that I put this arrow on W sub x. Well, then I'm never going to get away from the initial point. Remember that I want two components that lead us from the initial point to the final point, just like the overall vector does. The overall vector goes from this initial point to this final point. But these components now wouldn't work. If I try to follow along the x component, I can't move in this direction because the arrow is pointing in the wrong direction. So instead I should say that this is the x component, over here pointing in this direction. And then the y component has to take us in this direction. That way, following along the components, we can get from the initial point to the final point. I hope that was clear. All right, so Now we need to put in our sign again. We know that the magnitude of w sub y is 1.7. So what's the sign? Well, we can see that w sub y here is pointing in the negative y direction. Notice how we've chosen kind of northeast, or maybe I should say up and to the right, as the positive direction. Up and right is positive, but w sub y here is pointing down and left, which is the negative direction. The positive y direction is up and to the right. The positive y direction is up and to the right, but w sub y here is pointing down and to the left, opposite to the positive direction. So w sub y with the sign should be negative 1.7. The answer is not complete unless it has the correct sign.